All right, now we're going to do questions from exam 2, the practice, and I have received some requests, so I'm going to work the requested problems. Here we go. The first one is number 6, and the question says the past 5 monthly returns for Kentucky Jelly are 3.25%, 7.13%, negative 3.05%, 4.25%, and 6.75%. And it asks, what's the standard deviation? Now, if you're into inflicting pain on yourself, you could do this mathematically, but the easier way is to use the calculator. So here we go. Turn your calculator on and hit second data. This allows us to enter data, but the first thing I want to do is clear it out, because if we have data in there from previously, it will not be erased, and if there are more observations than what we're going to put in this time, those other observations will hang out there and give you grief. So here's how you do that. You hit second, clear work, and that clears it out. Now we can type these numbers in. 3.25, enter, arrow down. By the way, you got to hit enter or it doesn't work. And now I want you to notice it says Y01. We could do 2 sets of data here and do correlation and all that sort of stuff, but we're not going to do that, so just skip the Y's. X02, 7.13, enter, arrow down, arrow down. X03, 3.05, negative. One of the most common mistakes is students forget to put in the negative. Enter, arrow down, X04, 4.25, enter, arrow down, X05, 6.75, enter. That's all the data. I don't have to enter anymore. But here's what I'm going to do. I'm going to arrow down, and then I'm going to arrow back up. And I'm going to check all of these numbers and make sure that I have typed them in correctly. You say, wait a minute, that takes extra time. It's a whole lot better than having to figure out what you did wrong or getting the wrong answer. Now, how do we get standard deviation? I'm going to hit second and the number 8. Notice it says stat above the number 8. It comes up here and it says len. I don't know why, but I'm going to arrow down. And it says n is equal to 5. This is our first quality control check. 1, 2, 3, 4, 5. We have the correct number in there. If you've got an n bigger than the number of your sample, it means you forgot to clear out your calculator. I'm going to arrow down, and it tells us that the average is 3.666. Now, I could go ahead and calculate and make sure that's correct, but I am confident, since I put in the data correctly, that this is correct, and by the way, I don't need it. So I'm going to arrow down and see that I have a standard deviation of 4.0966, and that is the correct answer. So I didn't have to pick up my pencil even once to be able to do this problem. Now, what if instead they'd asked me to calculate the variance? Well, the variance is just the square of this s sub x. Now, a variance is usually done in decimal, so I'm going to say divide by 100. And then I'm going to square this thing, and that would give me the variance. One thing you got to watch out for. Never, 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 never use this number in my class. This is a population standard deviation. We do not have the entire population, so we're not going to use that number. Always stick with s sub x. The next question says, a security with normally distributed returns has an annual expected return of 16% and a standard deviation of 24%. The probability of getting a return between minus 8% and positive 40% in any 1 year is. So anytime you see them talking about probabilities, we look to the normal distribution, and they've already given you the hint here that it's normally distributed. Now, let's talk about how we calculate things for the normal distribution. What we're really trying to figure out here is how far away we are from the mean for each of these returns based on the number of standard deviations. So we're going to figure out something called t. And the formula for t is x minus x bar divided by s sub x. And this just represents the number of standard deviations away any given point is from the mean. And the first point that we have is minus 8%. So we're going to have minus 8%, and then we're going to subtract the mean. They tell us that the mean is 16%. And then we're going to divide by S sub x, which is the sample standard deviation of 24%. So if I do the math on top, I get minus 24%, and the math on the bottom, and divide by 24% on the bottom, tells me that that is minus 1 standard deviation. Now let's do the second one. The second one is positive 40% minus 16% divide by 24. It is plus 1 standard deviation. And if you think back to our normal distribution, we know that between plus and minus 1 standard deviation, we have 68.26% between plus and minus 1 standard deviation of the mean. And so it's really easy to figure out that the answer is 68.26%. If we'd come out minus 2 to plus 2, it would have been 95.44%. If it had been minus 3 to plus 3, it would have been 99.74%. And this last one would probably never be chosen because it would have to be plus or minus infinite standard deviations. If the daily returns on a stock market are normally distributed with a mean of 0.05% and a standard deviation of 1%, the probability of a stock market having a return of negative 23% or worse on a particular day is approximately. Okay, now first of all, these numbers are wildly wrong. So we're saying if they're we have a mean of 0.05% and a standard deviation percent of this, what is the probability? So we know we're looking at a normal stock distribution here, and we are trying to figure out how far away from the mean is this minus 23% in standard deviations. So once again, we're going to use t is equal to x minus x bar divided by s sub x. X in this case is minus 23% minus 0.05%, that's the mean that they give us, and the sample standard deviation that they give us is 1%. And so what I end up with here is minus 23.05. That means that we are 23 standard deviations to the left of the mean. Now let's do some interpretation here. Think about if we were plus or minus 3 standard deviations, we would have 99.74% of all the observations between plus and minus 3. That means in these two tails, we would have 0.26% left over. And if we divide that by 2, since we have symmetric tails, that means in this one tail it would be 0.13%. Now if this thing is 0.13% at minus 3 standard deviations, what is it at minus 23 standard deviations? Well, it's definitely less than 0.1%. In fact, it's almost 0. And so that's why 0 would be the correct answer here, because we are so far left of the mean. We are 23 standard deviations left of the mean. There is almost nothing out there. The correlation between a stock and the market portfolio is 0.7. The standard deviation of the stock is 40% and that of the market portfolio is 20%. Calculate the beta of the stock. Well, we have a formula for beta of stock I is equal to the covariance of stock I with the market divided by the standard or the variance of the market return. We do not have covariance here. What we have is correlation, and so we have to do some substitution. We know that the correlation is equal to the covariance divided by the standard deviation of each. So I'm just going to rearrange that and substitute in here for covariance the correlation times the standard deviation of the stock times the standard deviation of the market divided by the variance of the market. And something pretty cool happens here. This cancels out and this cancels out. And so we actually just end up with the correlation of the stock with the market multiplied by the standard deviation of the stock divided by the standard deviation of the market. And that correlation we're given is 0.7 multiplied by standard deviation of the stock is 40, of the market is 20. And you can actually do this math in your head. 40 divided by 20 is 2. And 2 times 0.7 is 1.4. And that's the correct answer. So if I were you, what I would do is have both of these formulas, this and this, on your note sheet so you won't have to do any algebra in the middle of the exam. A portfolio is composed of two stocks, A and B. A has a standard deviation return of 35%, while B has a standard deviation of return of 15%. The correlation coefficient between the returns on A and B is 0.55. Stock A comprises 40% of the portfolio. Stock B comprises 60% of the portfolio. The standard deviation on the return of this portfolio is, oh my goodness. Okay, there's going to be some really sticky stuff here, and your chances of screwing this up are huge. However, I will teach you how to minimize your chances of screwing up. First, let's talk about some variables here. We know that the weight of A in the portfolio is 40%, or 0.4. We also know that the weight on B is 60%, or 0.6. By the way, if your weights don't add to 1, you're doing something wrong. They also tell us that the standard deviation of stock A is 0.35, and the standard deviation of stock B is 15. When in doubt, always use the decimal. You can always convert back to percentage. In this case, if you used percentage, chances are that you would get the wrong answer, so we're not going to do that. In fact, I would say it's not chances are, it's definite that you would get the wrong answer. Okay, there's one more thing that they give us, and that is that the correlation between A and B is 0.55. Okay, since that correlation is less than 1, we know we're going to have some diversification benefits, so this is a good deal. But we need to somehow figure out what is the standard deviation for the return on this portfolio. We don't have a formula for standard deviation on the portfolio. What we have is a formula for variance of the return on the portfolio, but that's okay, because all we have to do is take the square root of variance in order to be able to get standard deviation. Okay, now we just need to use the formula, and here's the formula. XA squared times the variance of A plus XB squared times the variance of B plus 2XA XB. And the standard formula that we use says covariance of A with B. But we don't have covariance, we have correlation. So just like in the last problem, we're going to have to do some substitution. And so what we're going to substitute in there is correlation of A with B times the standard deviation of A times the standard deviation of B. And if you don't remember that derivation, you can go back and watch my lecture video. Okay, let's talk about what we're going to do here. We know that the weight on A is 0.4. We're going to square that. And to get the variance, we're just going to square the standard deviation. So that's 0.35 squared plus 0.6 squared. That's the weight on B. And the standard deviation of B is 0.15. We're going to square that. Plus 2 times the weight on A times the weight on B times the correlation of A with B, 0.55, times the standard deviation of A. I'm running out of room here. Standard deviation of A, which is 0.35, times the standard deviation of B, which is 0.15. Because remember, this thing is the correlation of A with B times the standard deviation of A times the standard deviation of B. Okay, now let's go through and do the math. And I'm going to show you on the calculator how to do this such that you hopefully won't mess yourself up. Here's what I'm going to do. I'm going to do this one and I'm going to store it in location 1. I'm going to do this one, store it in location 2. I'm going to do this one and I'm going to store it in location 3. I guarantee you, if you try to work through this all in one go, you will mess it up. So don't do that. Okay, so let's start out here on our calculator. 0.4 squared times 0.35 squared equals. I'm going to store that in location 1. The next one, 0.6 squared times 0.15 squared equals. I'm going to store that in location 2. Now for the long one, 2 times 0.4 times 0.6 times 0.55 times 0.35 times 0.15 equals. Store location 3. Okay, now in order to get this variance of the portfolio, I'm just going to say recall 1 plus recall 2 plus recall 3 equals, and I get this number right here. Now to get from variance to standard deviation, all we have to do is take the square root, and that gives me this number here. And remember, we're working in decimals, so in order to be able to get to percentages, I'm just going to multiply by 100, and it gives me the answer of 20.39%. By the way, my recommendation to you, if you see this problem on the exam and you're uncomfortable with it, just skip it and come back to it after you've solved simpler problems. And the reason is simple. The exam questions are all worth identically the same, and there are a bunch of easy ones that you could get while you're trying to work this one out. So save this one for toward the end. Standard deviation of return on investment A is 0.10, while the standard deviation of return on investment B is 0.04 if the correlation coefficient between the returns is minus 0.25. The covariance of the returns on A and B is. Well, if we remember back, the correlation of A with B is equal to the covariance of A with B divided by standard deviation of A, standard deviation of B. I'm just going to multiply both sides by standard deviation of A and standard deviation of B in order to get, and I'm going to swap sides here so don't freak out, covariance of A with B is equal to correlation of A with B times the standard deviation of A times the standard deviation of B, which is what we were using for our substitution earlier. Correlation of A with B is minus 0.25. Standard deviation of A is 0.10. Standard deviation of B is 0.04. And so I'm just going to get my calculator here and say 0.25 negative multiplied by 0.1 times 0.04 equals. I'm getting minus 0.001, which is the correct answer. Your investment has a 40% chance of earning a 16% rate of return, a 50% chance of earning a 10% rate of return, and a 10% chance of losing 4%. First thing I'm going to point out to you is anytime they say losing, you have to say that's a minus. Most common mistakes students make. What is the standard deviation of this investment? Well, this is not one of them that we can solve with our handy dandy data or stat on our calculator. We're going to have to do this one the old fashioned way with a pick and blowtorch. So here's what I want to do. The first thing I want to do is set up we're going to set up a table here, and my probabilities are going to be 0.4, 0.5, and 0.1. And if your probabilities don't add to 1, you've done something wrong. Go back and check it out. Okay, now the return on each one of those in those scenarios is given. So we've got a 16% return here, a 10% return here, and a minus 4% return here. Now, once again, if you are uncomfortable knowing whether to use percentages or decimals, go ahead and use decimals. I know that we're going to be taking the square root of this thing to get back to standard deviation, so I really don't have to mess with it at this point, but if you're uncomfortable, you do what makes you feel best. Now, the first thing we're going to have to do is figure out the expected return for this investment. And that's easy enough to do. It's just 0.4 times 16% plus 0.5 times 10% plus 0.1 times negative 4%. Got to remember that negative. Now, most people will screw this up getting in the calculator, and they'll screw it up based on order of operation. So here's what we're going to do. We're going to do this math, we're going to store it in location 1. We're going to do this math, we're going to store it in location 2. We're going to do this math, and we're going to store it in location 3. And then we're going to add them all together to get our expected return. So here we go. 0.4 times 16 equals store 1. 0.5 times 10 store 2. 0.1 times 4 negative equals store 3. Now I'm going to add all those together to get my expected return. Recall 1 plus recall 2 plus recall 3 equals, I'm getting 11%. Now I'm going to be using that number over and over again to get my deviations from expected return. So here's what I'm going to do. I'm going to store that thing in location 0 because I'm going to use it over and over again. And so I'm going to go ahead and write there that I have stored that in location 0. Okay, now, if we're figuring standard deviation, our very next thing to do would be to take the return minus the expected return. This is known as our deviation. And the next column over is going to be our deviation squared. And our final column will be the probability for the scenario times the deviation squared in that scenario. Then we're going to sum all those up, and that's going to give us the variance. And then we're going to take the square root to get to the standard deviation. Now, here's what happens. Most students want to work this way. They work in columns. And that means that they're constantly either storing numbers or writing them down. And I'm going to tell you that is the least efficient and most error-prone way to work these problems. What you want to do is work across. I'll demonstrate. We're going to start here with 16, our first return, subtract, recall 0, equals. And so our first deviation here is 5%. Now, I don't even have to write that down. I'm just doing it for your sake. Now, the next column over would be to square that, and that's going to be 25. And then the final would be to take that and multiply it by the probability, which is 0.4. And I'm getting 10. And so I'm going to write that down. But I am actually going to store this in location 1. And I would suggest you do the same thing. I'm going to do it again just in case. Store 1. There we go. Now, as I go through here, I'm not going to be writing these down. I'm just going to be walking through mentally, and then I will store this one in location 2 and this one in location 3. So here we go. 10 minus recall 0 equal. So that deviation is negative 1. And when I square a negative, of course, I get a positive, and 1 times 1 is 1. So that's my deviation squared for this middle one. And then I'm going to multiply by the probability and say equals. That's going to be number 2. So I'm going to say store 2. Now, I've got 4 negative. Got to remember the negative. 4 negative minus, recall 0 equals. Now my deviation is negative 15. I'm going to square that. Of course, the negative goes away, and my deviation squared is 225. Then I multiply by the probability of 0.1. It gives me 22.5 for my probability times deviation squared. I'm going to store that in location 3. Okay, so now I'm going to calculate, by the way, these all add up to the variance. And so recall 1 plus recall 2 plus recall 3 gives me 33. How do I get from variance to standard deviation? All I have to do is take the square root, and that gives me 5.74%, which is the correct answer. Okay, here we have a 7.5% coupon bond with 9 years left to maturity, priced to offer an 11.2% yield to maturity. You believe that in 1 year the yield to maturity will be 8%. What is the change in the price of the bond in dollars? And they tell us to assume the interest payments are semi-annual, so there's going to be 2 of those per year, and the par or face value is $1,000. So here's what I would do if I were you. I would set up 2 sets of inputs, and I would go ahead and fill these out as I go. Now, let's talk about the first situation at time 0. We've got 9 years left to maturity. That means if you get 2 coupons per year, n is going to be 18. Now, here's the interesting thing, and this is what most students miss out on. After a year, you're only going to have 8 years left to maturity. So the number of coupons for your second calculation is just 16. Okay, now, what about the yield to maturity? Well, they say it starts out at 11.2, but we know we have to divide that by 2 because we have semi-annual coupons. And so my yield to, or my I per Y here is going to be 5.6. For the second bond, it's going to go down to 8% and divide by 2 gives us 4. 8 divided by 2 is 4. Okay, now, one of the things that stays the same for a bond is the coupon payment. So let's figure out what that coupon payment would be. It's a 7.5% bond, and we said if it's a $1,000 face value, all we have to do is multiply by 10 to get the annual coupon paid, and then we have to divide by 2 to figure out what our semi-annual coupon amounts are. So that's $37.50. That's the same for both of these, as is the face value or future value or par value stays the same at 1,000. So what do I do now? Well, I'm going to figure out the present value because that is the price of the bond. So get your calculator and say clear second, clear TVM, just in case there's other junk left in your calculator from previously. And we're going to say 18 N 5.6 I per Y 37.5 PMT and 1,000 future value. By the way, does it matter what order I put them into the calculator? Absolutely not. So now we're going to compute present value, and I'm getting $793.53. Remember that negative on the present value is a result of the sign convention, but I'm actually going to take advantage of it. I'm going to hit clear just one time. Oh, crap. Okay, how about compute present value, and I'm going to hit store 1. There we go. Now we got rid of the PV. I've stored that, and I've stored it as a negative because we're going to subtract it from the next value in order to find the value change. Okay, now notice that there are only two things that have actually changed here. I could clear everything out and re-enter everything, but why would I do that? Because I am so lazy. Here's what I'm going to do. I'm going to say, wait a minute, I'm just going to change 16 to n, and I'm going to say 4I per y, and then I'm going to compute present value again. And this time I'm getting $970.87. Okay, in order to figure out the difference, here's the first thing I'm going to do. I'm going to hit my plus minus to get rid of that negative sign. And then I'm just going to say plus, recall 1. And the reason I can add it is because we left it in there as a negative. If that freaks you out, you could have changed the sign on it, stored it as a positive, and then subtracted it. But it works either way. And so we know that we have $177.34 increase in value, which is the correct answer. A 5.75% coupon bond with 12 years to maturity is offered for sale at $828.47. What yield to maturity is the bond offering? Now they give us some important information here. The coupons are paid semi-annually. I didn't even have to tell you this part because that is the default assumption unless you are told otherwise. So what have we got here? Well, we know we've got 10 years or 12 years left to maturity, and semi-annual coupons. 12 times 2 is 24 coupons left. And we also know the coupon rate on the bond is 5.75. To figure out our annual amount of coupon paid, we simply multiply by 10 because the face value is 1,000, and that gives us $57.50. So payment is equal to half that. So I'm going to divide by 2, and that tells me that our coupon payments are $28.75 each. Now, we also know that the future value is 1,000. We know the current price of the bond. It's just the present value, or the present value is the price. But I have to remember that in the TIBA2 plus, the sign convention, cash flows in opposite directions have opposite signs. Our future value is a cash flow to us, so we call it positive. The payment is a cash flow to us, we call it positive. The present value, or price, is a cash flow away from us. That's the investment we have to make in order to get this sweet deal. And so I'm going to write that down as a negative $828.47. And so then I'm going to put all this into my calculator and I'm going to compute I per Y. First thing I'm going to do is clear out my time value of money. Second, clear TVM. And notice I've left the coupon amount in there. I'm just going to go ahead and hit payment, and that way I didn't have to redo that math. 24N, 1,000 future value. And then we put in our present value, 828.47 negative present value. And I'm going to compute I per Y. Now, this is where most students stop. And they say, oh, hey, look, 4%, it's one of the answers. It sure is, because it's the most common mistake. So, what is the actual answer? Well, remember that this is the return just for a 6-month period. So that means we've got to multiply this by 2 in order to get it to be an APR, which is how we express yield to maturity. Because there are 2 of those subperiods per year, we multiply the subperiod rate times 2. And that tells us that the yield to maturity for this bond is 8%. A coupon bond pays interest of $80 annually. Ooh, we got to make note of that. Has a par value of 1,000, matures in 5 years, and is selling today at a 75.25 discount from par value. Now, this is where it comes in important to actually read, because they're not asking for yield and maturity, they're asking for current yield. So here's what we're going to do. Current yield is equal to the annual coupon divided by the price. Okay, they tell us the annual coupon is 80. But what is the price? Well, they don't tell us directly. What they tell us is that it's selling at a 75.25 discount from par value. So this bottom part is going to be minus 1,000 minus 75.25. How do I do that in my calculator? I'm going to say 80 divide by, open parentheses, 1,000 minus 75.25, close parentheses, equals. And I'm getting 8 points. Oh, by the way, I can multiply by 100 to get it in percentages, and that's 8.65%. Most common mistake students make is they try to figure out yield and maturity here, and that's going to get you into the wrong area. Always read first. What is the taxable equivalent yield on a municipal bond with a yield to maturity of 4.55% for an investor in the 35% marginal tax bracket? So if we think back to our formula, we said that the interest on a municipal bond was equal to the interest on an otherwise similar taxable bond multiplied by 1 minus the taxpayer's individual marginal rate. Now, we can rearrange this and divide both sides by 1 minus t and find out what we call the taxable equivalent yield, or I sub t. And in this case, we have a yield to maturity on our municipal bond of 4.55%, and our taxpayer has a marginal tax rate of 35%. And so here's how we're going to do this in the calculator. We're going to say 4.55 divide by, open parentheses, 1 minus 0.35, close parentheses, equals 7%. And 7% is indeed the correct answer. If the nominal interest rate is 12%, the inflation rate is 5%, what is the real interest rate? Now, if you were just using the approximation, you would take 12% minus 5%, and you would get 7%, and you would be wrong. Because I've told you in my online lectures and in my seated classes, you should only use the approximations for your conversations after work at the bar, on the back of an envelope, or a cocktail napkin. For anything involving test answers or real money, you always use the full Fisher effect equation. And here's the full Fisher effect equation. 1 plus big R is equal to 1 plus little r times 1 plus h. Now, what do these things mean? This is your nominal rate of return, which is the rates that we observe out there in the wild when you borrow money at the bank, or when you're looking at returns on your stocks. This is what you're seeing. There's the real rate of return, which represents your increase in your ability to consume as a result of having made the investment. And then we have inflation, which is H. Now, you may see someone else, one of my colleagues, use pi here. And in fact, others do it too. I use H. By the way, we don't use I because people get confused with interest rates. But I use H here. And the reason is I don't want you to confuse it with interest, and I certainly don't want you to confuse it with a mathematical constant of 3.1416, blah, blah, blah. Okay, now, this thing is asking for what's the real rate of interest. So we are looking for little r. So the game here is going to be to get little r by itself. And the first thing I'm going to do is divide both sides by 1 plus h. And so I'm going to say 1 plus r divided by 1 plus h is equal to, is equal to 1 plus little r. Now, I need one more step to get little r by itself. I'm going to say 1 plus r divided by 1 plus h minus 1, and that's going to be equal to little r. And keep in mind that's going to be as a decimal. We're going to use decimals in here. If we use the full percentages, we will get it wrong with certainty. Okay, here we go. We've got 1.12 divided by 1.05 equals 1.066666. And then I'm going to subtract 1. I'm I'm going to multiply by 100 to get it into percentages, and I see that my answer is 6.67%. Transportation stocks currently provide an expected return of 12%. TTT, a large transportation company, will pay a year-end dividend of $3 per share. If the stock is selling at $60 per share, what must be the market's expectation of the constant growth rate of TTT dividends? Okay, we're going to have to do some tricky stuff here. First of all, we have to decide whether this dividend they tell us about is D1 or D0. How do we know which it is? Well, they say will pay a year-end dividend. That tells us it is D1 because remember anything future tense 1 year or less we're going to call D1. So we're going to say D1 is equal to 3. And then the stock selling at $60 per share, we call that P0, the price at times 0, and that's 60. And further, they tell us that transportation stocks require a return of 12%. And so that is going to be R. And I'm going to put it into decimal form. Okay, and now they're asking us, though, what is G? So I have a formula that includes these three things and this. All I have to do is solve it for G. And here is that formula. The total return is equal to D1 over P0 plus G. We've seen this before in the lecture. We know this is the dividend yield. This is the capital gains yield, which is also the same as the growth rate of the dividends. And so all I'm trying to do is get G by itself. So what I'm going to do is subtract D1 divided by P0 from both sides. So this is going to be R minus D1 over P0 is equal to G. Now all I have to do is plug my numbers in. R is 0.12 minus D1 is 3 divided by 60. And that's equal to G. If I do the math, this is 0.05. And so here's how I can do that on my calculator. I could say 0.12 minus, open parentheses, 3 divided by 60. There's my 0.05 equals 0.07. And that is the correct answer. Our growth rate is 7%. I could have also asked, what is the capital gains yield for this stock? And the answer would have been exactly the same because G represents both for stocks with constantly growing dividends. Universal Vacuum is a no-growth firm. G equals 0. Has 4 million shares outstanding. It expects to earn a constant $20 million per year on its assets. It has no debt. All earnings are paid out as dividends, and the cost of capital is 10%. Calculate the current price per share of the stock. So this is what we would refer to as a cash cow stock. Because there are no growth opportunities, we don't have to invest in new assets. And so as a result of not having to invest in new assets, we can pay out all of our dividends as, all of our earnings as dividends. And we said that the way you value a cash cow firm, the P sub 0 here, we could use our regular constant dividend formula is D over R. But we said we're paying out all of the earnings per share as dividends. And so the value is actually EPS over R. Now, how do I get earnings per share here? Well, they tell us that the firm is earning $20 million per year, and they tell us that there are 4 million shares outstanding. Those millions cancel out, by the way. Divide by the required return. Cost of capital, 10%, 0.10. So if I do 20 divided by 4, hopefully you can do that in your head. We're actually looking at 5 divided by 0.10. Hopefully you can do this one in your head too, but here we go. 5 divided by 0.1 equal 50. And so that is the correct answer. firm does not pay a dividend. It is expected to pay its first dividend of 54 cents per share in 3 years. The dividend will grow at 9% indefinitely. By the way, indefinitely means forever. Using a 10% discount rate, compute the value of this stock. First thing you want to do when you get a problem like this is draw a picture with a timeline. And so it says 3 years. So I'm going to go 1, 2, 3, 4, 5, just for the fun of it. This is time 0, time 1, time 2. And they tell us that the first dividend will be paid in time 3 and that it will be 0.54, 54 cents per share. Then they tell us that this is going to grow at a rate of 9% indefinitely. And they also tell us that the required return is 10%. Okay, now we have enough information that we can figure out P2. Now remember, if we've got D1, P sub 0 is just D1 over R minus G. And it turns out it doesn't matter what these two numbers are. All that matters is that this one be 1 greater than this. So if we're given D3 divided by R minus G, we can figure out pretty easily P2. So let's go ahead and do that. 0.54 divided by 0.10 minus 0.09. Okay. 0.54 divided by open parentheses 0.1 minus 0.09 close parentheses equal. So the price at time 2 is $54 a share. Now you have to be careful because that's one of the answers, but you're not done yet. And here's why. That value of P2 is there at time 2. We're going to have to take that back 2 years in history. How do we do that? Well, we call that time 2 number our future value. And then we're going to say we're going to take it back in time 2 years. I per y is equal to 10. And we're going to compute PV. Now this is where it's extraordinarily important for you to clear out your calculator because we have PMT in there from earlier. If I don't clear my TVM, that PMT is going to be hanging out there waiting to give me a bad answer. So here's what I'm going to do. I'm going to say second future value, clear out my time value of money keys. And I'm going to put in 54 for the future value, 2 for n, and I'm going to 10, I per y. And then I'm going to compute present value. And when I do, I get $44.63, which is the actual correct answer. A firm has been losing sales due to technological obsolescence. It projects growth for the future to be negative 7%. In other words, the company is shrinking. Its recent dividend was $2. What's the value of this stock when the required return is 9%? Okay, a couple of things here. First of all, students assume that we shouldn't buy stock in companies that are shrinking. I'm going to prove to you that they still have value. The second thing is we have to figure out whether this is D1 or D0. And when it says its recent dividend, that's in the past or present, so we're going to call that one D0. If it had said its next dividend will be, it would have been D1. So it's asking what the value of the stock is when the required return is 9%. P sub 0 is equal to D1 over R minus G. But we don't have D1. But we can substitute for us because remember D1 is just D0 times 1 plus G. And so that's what we're going to do. We're going to substitute that in because those things are exactly the same thing. So let's go ahead and put our numbers in. D0 is 2 multiplied by 1 minus 0.07 because we have that negative growth rate. Divide by R, which is 0.09 minus 0.07. By the way, that's the most common place students screw up, is they say 0.09 minus 0.07 down here. Don't do that. Okay, let's go ahead and figure this out. Up on the top, order of operations says 1 minus 0.07. So the first thing I'm going to do, I'm going to multiply by 2. And that's going to give me $1.86. We could have done it exactly. We could have said 2 times, open parenthesis, 1 minus 0.07, close parentheses, equal, and get exactly the same answer. Okay, now I'm going to divide that by open parenthesis, 0.09, minus times a minus is a plus, close parenthesis, equal, and that's going to give me $11.63, which is our answer. And then we have our very last problem. The Intech company just paid a dividend of $2 per share. We know that is D0. Analysts expect its dividend to grow at 25% for the next 3 years, that is G1, and then 5% thereafter, that is G2. If the required rate of return is 18%, that's our R, what's the current value of the stock? And so this is one of those differential or supernormal dividend problems. And as I've said in class and in my video lectures before, if you run into one of these, skip it and save it for the end of the exam. And once you've done your other questions, come back and give it a try. And the first thing you're going to want to do is draw a picture. And that picture, we are going to have some years on it. And then we're going to start reading through the problem. They start at time 0. We do not receive D0, but it's important for us because we're going to use it to calculate D1. It's important for one other reason, because they tell us that analysts expect the dividend to grow at 25% per year for the next 3 years. Well, since they gave us D0, that's where we start our count from. And remember, we're going to use the kindergarten method. We're going to start with the dividend they give us, and then we're going to count off the number of years. They say for the next 3 years, so here we go. 1, 2, 3. That tells us that our constant dividend payment starts at year 3. And so these dividends are going to grow relatively quickly up until year 3, and then there's going to be a regime change where they grow at a slower rate. So this is going to be G1, and this is going to be G2. Now our process for solving these tells us the first thing we need to do is solve for the dividends up to and including the start of constant growth. The second step will be to find the price at the start of constant growth. So let's talk about how those are going to go into our calculator. C of 0 is equal to 0 because, after all, you do not get D0. C01 is D1. C02 is D2. C03 is D3 plus P3. Remember, we said that someone else collected D0 right before they sold the stock to us for P0? Well, we're going to collect D3 just before we sell the stock to someone else for P3. And why is this P3 important? It represents the present value of all the dividends going out into the future. So instead of having to worry about each one of those dividends, I can account for them all with a single number here, the price at time 3, which of course we'll have to bring back in time to time 0 to figure out its value. That's why it's out here at time 3 in our cash flows. So let's get our calculator out and walk through this. But one last thing, remember that D1 is equal to D0 times 1 plus G. Our D1 is going to be equal to D0, which is 2, times 1 plus, and by the way, we're talking about G1 here, which is 25%. 1 plus 0.25, that means our first dividend is going to be $2.50. If you don't believe me, you can use your calculator to figure that out. Okay, so here we go. Here's what we're going to do with our calculator. First thing we're going to say CF. Second, clear work. And the reason you want to do that is because your calculator remembers what you've done, and if you have more than 3 cash flows out there, they will stay out there and mess you up. So don't give your calculator that opportunity to mess with you. Just say second clear work, and it clears all those out. Now C of 0, we do not receive D0, so we're going to arrow down. And we said that our D1 is $2.50, so we're going to say 2.50. Enter. And we're going to do something else. We're going to say store 1. By the way, I've got to do both those. And the other thing you need to know is enter and equal are not necessarily the same thing. So when I say enter, make sure you're actually using the enter key. Arrow down to C02. By the way, all of these dividends are different, so all of our frequencies are all going to be 1. How are we going to get C02? Well, it turns out that D2 is just D1 times 1 plus whatever the growth rate is. And so we're going to say recall 1, that's D1, and we're going to multiply by 1 plus the growth rate, which is 1.25, equal to, that's going to give us dividend 2. At this time, I want to hit enter, and I also want to hit store 2. Arrow down, C03, how am I going to get it? Well, I'm going to start with dividend 2, recall 2, and I'm going to multiply by 1 plus that first growth rate, which is 1.25. That's going to give me this number, which I'm going to store 3. So now I have D1, D2, and D3. I just need P3. Now here's what you need to know. P3 is equal to D4 divided by R minus G. Remember we said this one just needs to be 1 less than that. We don't have D4, but we do have D3. And we can say 1 plus G, and by the way, this is growth rate 2, because now we're growing at a slower rate. Okay, so what we're going to do is take D3 times 1 plus G2, and G2 is 5% or 0.05. So here we go. This is D3 currently in my calculator. To get to D4, I'm going to multiply by 1.05 equals. So far, so good. Now I need to divide by R minus G2. The required return is 18%, and our second growth rate is 5%. So here's what I'm going to do. Divide by, open parentheses, 0.18 minus 0.05, close parentheses, equal. And so this would be my price at time 3. But remember, C03 is not just price at times 3, it's price at times 3, time 3, plus the dividend at time 3. Well, fortunately for me, I have that stored in location number 3. So I'm going to say plus recall 3. That gives me my entire cash flow at time 3. I'm going to hit enter. Now remember that the price or value of anything is the sum of the present value of all the expected cash flows discounted at a rate appropriate to the risk. How are we going to get that number here? Well, we're just going to hit the NPV button, and we're going to put in our required rate of return, which is 18, enter, arrow down, and we're going to compute that net present value. And that net present value comes out to be $25.94. That is the value of that stock today.